So when you look at the scientific notation, you would have a number is written in terms of decimal point after the first non-zero digit multiplied by a factor of 10. So this is like a format of the scientific notation. You get one number times 10 to the power of any number plus or minus. So we're going to take a look at some examples here. So a number is written in scientific notation in the form of a times 10 to the power of n, where absolute value of a is between 1 and 10. So this number has to be between 1 and 10. So it would be 0.1 or 0.2. And then n could be either plus or minus. So let's take a look at some example. 8,500. If I want to write 8,500 as a scientific notation, the decimal point originally is right front of the last zero. So I have to move this decimal points right front of 8 to make it between 1 and 10. So it would be 8.5. Now, since I'm moving these 3 units to the left, so this would be 10 to the power of 3. Now the question is it plus 3 or minus 3? Now, common sense tells me that this number is larger than 1. 8,500 is larger than 1. So when you're done with writing in scientific notation, this better be plus 3. Otherwise, the negative 3 would correspond to the number less than 1. So remember, when you write a number times 10 to the power of minus exponents, that corresponds to a number less than 1, right? So 8,500, when I move this decimal right front of the last zero 3 units to the left and make this 8.5, because I moved the 3 units to the left, that would be the same as 10 to the power of minus 3. However, if I have 0.230 times 10 to the power of 4, this a is less than 1. In this case here, 46.5 times 10 to the power minus 3. This a is greater than 1, so that's not a scientific notation. You want to make sure this number here is between 1 and 10. So 46.5 times 10 to the power minus 3 is not a scientific notation, right? However, this number here would be, has to be between 1 and 10. Okay, so this is not a scientific notation. Let's take a look at some more examples to make it a little bit more clear. So if I have this number here, 29, and then you have 800 followed by 3 zeros, right? 29,800,000. So you want to write this as a scientific notation. The decimal point is right in front of the last zero originally. I need to move that right front of 2 to make this number between 1 and 10, right? So when I do that, this would become 2.98. This number becomes 2.98 times 10 to the power of, let's see how many times you move that decimals. 1, 2, 3, 4, 5, 6, 7. So that's why we have 10 to the power of 7. We'd be positive 7 because, again, this number originally is larger than 1. So this must be plus 7. So take a look at some other examples. Like this number here obviously is less than 1, right? It's a very small number. So I know if when I write this in scientific notation, it has to be 10 to the power of some negative number. So I need to move this decimal points right front of 5 to make this number between 1 and 10, right? So that becomes 5.03. 5.03. That number is less than 10. And then see how many times you're moving this. 1, 2, 3, 4, 5, 6, 7, 8 times. I moved it 8 times to move that decimal right in front of 5. So that's why this would be equal to 10 to the power of 8. Would be minus 8 again, because just by looking at this number originally is less than 1. Then the number is a very, very small number. then this has to be minus 8, not plus 8. So that's how you can kind of look and see whether it's plus or minus. So compare these two again. This 29 million is a number that is obviously larger than 1. So at the end you add 10 to the power of plus 7, whereas this one is less than 1. It turns out to be negative. So that's how you can figure out if it's whether positive or negative. That's one way to remember it. At the end, should we put negative or positive exponent? So now we know how to deal with scientific notation and how to write this in terms of scientific notation. We can look at some more examples. Write each number in standard notation, and we can go back and change it in the standard notation backward. Here you have 2.51 times 10 to the power of 3. We're going to move the decimal points 3 places to the right. So that would be 1, 2, 3. That becomes 2,510. Okay. The next one, minus 6.8 times 10 to the power of minus 4. We want to move the decimal point 4 places to the left because this is minus 4. So if you move this decimal 4 places to the left, it becomes minus 0.00068. So you should be able to write this back and forth from standard notation to scientific notation, and vice versa. So let's take a look at the next example. So you can use this idea to evaluate the numbers like these, that is very large number or very small number. In this case, we have 200,000. All right, 200,000 as 2 times 10 to the power of 5. And if I write 0.0003 as 3 times 10 to the power of minus 4, and change everything in scientific notation, 0.06 as 6 times 10 to the power of minus 2. Now I can multiply 2 times 3 divided by 6. 2 times 3 divided by 6 would be 6 over 6, which is 1. Now I can use my properties that I just learned. 10 to the power of 5 times 10 to the power of minus 4. That gives me 10 to the power of 4 plus minus 4, which is equal to 1. Over 10 to the power of minus 10, I can subtract, now the quotient rule. So I have to subtract negative 2 from 1. So the whole thing would be 10 to the power of 1 minus minus 2, which is 10 to the power of 3. So that would be 1 times 10 to the power of 3, which is equal to 1,000. So you can use the scientific notation to compute very large number, very small numbers in this case.